The next presentation has been provided by Humura Kafi, who's been unable to attend the meeting. So it will instead be presented by Martin Donnelly from the Liverpool School of Tropical Medicine. He's a professor of evolutionary genetics, and his main area of interest is the evolution of insecticide resistance in Anopheles malaria vectors.
So in order to catch up a little bit on time, I'll dive straight into a little bit description of the Sudanese study site. So in Sudan, the study was conducted in 140 clusters, which were distributed across 4 areas. El Housh and Hag Abdullah are contiguous areas in Gizur State. Galabat and New Halfa. Galabat is down towards the Ethiopian border, and New Halfa is in Kassala State over to the east of the country. So in this setting, malaria is mainly transmitted by Anopheles arabiensis and is tests were introduced to at the start. This is now relatively low malaria endemicity. So in advance of the study being implemented, there are a range of vector control methods used across these 4 study districts, ranging from LLNs with deltamethrin to IRS in some cases with bendiacarb. Pyrethroid resistance had been observed through bioassay, WHO bioassays across all 4 study areas. And where this study differs from the 3 previous presentations is that studies here were randomized to a 2-arm trial where we were comparing long-lasting nets, these are deltamethrin treated nets, to long-lasting nets with the addition of indoor residual spraying. And again, as Tessa mentioned earlier, in 3 locations, 3 study cluster districts, this was the bendiacarb was the active ingredient, and in Galabat there was a switch from pyrethroid to deltamethrin in year 2011 and 2012 to 2013 when we used bendiacarb. So in each of the 140 study clusters, there were 200 children under 10 who followed. So we have a cohort size of around 7,500 across each of our study locations. So data that we'll be talking about today are the results of the active case detection, which we conducted, and also cross-sectional malaria prevalence indicator surveys. As I say, mosquitoes species here is partially redundant because this is solely an Anopheles arabiensis transmission zone. Insecticide susceptibility against deltamethrin was again conducted in 60-odd clusters, and we also have KDR frequency data because KDR frequency here was not at fixation, so we actually maybe had some explanatory power to look at the association with epidemiological indicators. So again, the recurrent story here is that there's a marked variability in phenotypic estimates of resistance across study areas. What these data don't show is that there's very poor inter-year correlation in insecticide resistance on a cluster-by-cluster specific basis. So there's massive amounts of temporal and spatial heterogeneity. There was an increase in resistance over the course of the study, so this was a significant change. And you can see here that it was possibly coincident with the second round of LLI distributions which happened in 2014 in advance of the phenotypic assessments. So deltamethrin is problematic and increasing in the area. Looking at the KDR frequency in Anopheles arabiensis populations here, so we have a series of 5 data points here from each of the 4 study locations. What you will immediately notice is that there's this leap from 2010 to 2011. That's going from the blue to the green box whiskers there. The 2010 data were used for balancing the randomization. We weren't able to get phenotypic data from across all 140 clusters, so we used KDR as a proxy. And then between 2010 and 2011, the LLINs are distributed, so that may be partially explaining why they have that increase in frequency, although over the duration of the study, quite unusually, we start to see a decay in KDR frequencies in all study areas. So we'll take you through a snapshot of both the case incidence data and the prevalence data. And so we have 2 tables here. The table on your left is actually looking at phenotypic measures, and the table on the right is using KDR frequency. So you can see in 2012 to 2014, we were able to get phenotypic estimates of resistance in 51 clusters, and obviously associated epi indicators. So looking at this as deltamethrin resistance or susceptibility is linear. What we see here is that there is no evidence of, You can see here, number of cases, relatively low disease malarial incidence in this setting, and you can see here no significant evidence of any association between deltamethrin susceptibility and case incidence. And that's also mirrored in the larger data set, because also we're able to get genotypic frequencies from across all 140 clusters, and again, no significant estimate of change in case incidence in relation to changing KDR frequency. To look at prevalence data and also using this dichotomization approach. So here, data from 2012, but representative of the findings throughout the study. What we're seeing here is that we dichotomize based on deltamethrin resistance phenotype. We show limited differences in prevalence and no association by prevalence and level of phenotypic resistance. And again, using the KDR as a proxy of resistance, again dichotomizing, we again see no evidence of a significant difference in prevalence associated with KDR allelic frequency. Just to focus on the area where we had the switch from deltamethrin to bendiacarb IRS, Galabat in Sudan, we had 26 villages within this area. So they were randomized to one of two arms, LLINs with universal coverage or LLINs plus indoor residual spraying. And we'll talk about data from 2012 when deltamethrin was used, and we'll compare that to 2013 and 14 when bendiacarb was the active ingredient of choice. So again, looking at deltamethrin and KDR frequencies, here there was this decrease in KDR frequencies we've been observing across the study community, so no significant change over here. But what is noticeable and what was significant was this possible retardation of emergence of deltamethrin resistance in the dual intervention arm. So you can see here no significant difference in when they was using deltamethrin as IRS. This is the first year post bendiacarb, and this is the second. And what we may be seeing here is a significant retardation in the evolution of insecticide resistance when you're using a second active ingredient for which there's no resistance. So bendiacarb, these populations are fully susceptible to bendiacarb. So quite a positive message there. And quite strikingly is when we observed the shift from deltamethrin to bendiacarb use, you can see this marked fall between 2012 and 2013 in malarial incidence. And if you compare that across the control group where there's just a single intervention, where there's no evidence of change in malaria incidence over time, and what we can look at here is that it seems to be essentially a halving of malarial incidence following the switch from deltamethrin use to bendiacarb use. So again, showing a really strong impact of the use of an effective IRS agent. So to conclude, Anopheles arabiensis is the only member of the Gumby complex present in this area. Deltamethrin resistance is widespread. Bendiacarb resistance wasn't observed, and hence we had a very marked effect with the use of bendiacarb IRS. There was no association between malaria incidence and prevalence and deltamethrin susceptibility or KDR frequency in this area. And there was strong evidence of that deltamethrin IRS provided no additional protection to long-lasting nets, and that the switch to bendiacarb almost halved malaria incidence. And there's some evidence of retardation of the evolution of resistance as well. So obviously Hamuda and Bashir would like to thank both the funders and the numerous participants and contributors to the study. And with that, I'll thank you.